This is Chapter 6, Section 6 notes. Today we're going to be working with systems of inequalities. So this is going to be two or more inequalities at the same time. So problem 1 says determine whether the ordered pair is a solution of the given system. So the ordered pair we're given is 8 and 2, so that's the x and the y that we're going to have to plug in. Now our inequalities are 3x minus 2y is less than or equal to 17. And 0.3x plus 4y is greater than 9. So I'm just going to go ahead and plug in 8 for the x and 2 for the y's. So I'm going to go ahead and do that on both equations, or inequalities. So I have 3 times 8 minus 2 times 2 is less than or equal to 17, and 0.3 times 8 minus 4 times 2 is greater than 9. So now it's just a matter of solving these. So 3 times 8 minus 2 times 2, so 24 minus 4 gives me 20. Is 20 less than or equal to 17? The answer is no. So then I go to the other side. 0.3 times 8 minus 4 times 2. So 2.4 minus 8, is that greater than 9? So 2.4 minus 8 is negative 5.6. Is negative 5.6 greater than 9? The answer is no. Now, I actually don't need both of these to be no. As long as one is no, the solution will not work for both. So you just need one of these two to be no in order for it not to work. If they're both yes, then that number would work for both inequalities. Okay, so number 2, what is the graph of the system? So we are going to go ahead and graph both of these inequalities on the same graph. So y is less than 2x minus 3, and 2x plus y is greater than 2. So for this first one, because y is first, I can just use the slope and the y-intercept. So y-intercept of negative 3, slope of 2 over 1. Now there's no line underneath the symbol, so it'll be a dashed line. Plugging in 0, I have 0 is less than negative 3, which is going to be a no. So I can graph it by starting at negative 3, go up 2 over 1, up 2 over 1, connect with a dashed line, and then shade on the side that does not have 0, 0 on it. This next one is going to be a little bit different. Because x and y come before my symbol here, I'm going to have to cover up. So if I cover up the 2x, I'll get y equals 2, which is right here. If I cover up the y, I get 2x equals 2. Dividing by 2, I'll get x equals 1. So I'm going to go ahead and graph those 2 points. Y equals 2, so that'll be a 2 on the y-axis. X equals 1, that'll be a point on the y-axis. And again, this doesn't have a line underneath it, so those will be connected with a dashed line. If I plug in 0, 0 plus 0, is that greater than 2? Is 0 bigger than 2? No. So I'm going to shade on this side of the line that does not have 0 on it. So I did this using 2 colors, and that's what I would highly, highly, highly recommend. So this is what it looks like. Okay. So this first line, negative 3, is where I started. And I went up 2 over 1, up 2 over 1, up 2 over 1. And I connected that with a dashed line, and then I shaded that side of the line because 0, 0 is over here. Then I went to this one, and I put a dot at 1, and I put a dot at 2, connected them with a dashed line, and shaded this side of the line. I used blue for my second line because it makes it easy to see where they overlap. This overlapping region is actually your answer. All of the numbers or coordinates in this section of the graph will be the solutions to both of these inequalities. So that's what you're looking for, is the overlapping part. Okay, so you graph them both on the same graph, and you just are seeing where they overlap. So now we're going to do this in reverse. They actually give us the graph, and we need to actually write out the system of equations. So to do that, I like to use the slope and the y-intercept. So for this dashed line, I have a nice point here. That's at 1, 2, 3, 4, 5. So my y-intercept is at 5. And then if I count, I go down 1 over 2. So negative 1 over 2 is the slope. I'm going to use, because the 0, 0 is shaded, I'll use a less than sign. So I'll have y is less than negative 1/2 x plus 5. Kind of like y equals mx plus b. I have my slope, I have my y-intercept, you just are putting it in an inequality. Now because this is dashed, I want to make sure that I do not have a line underneath that less than sign, it's just y is less than. This next one, my intercept right down here should be at negative 1. I'm going to go up 1 over 1, so my slope will be 1. And it's a solid line, so I'll have a negative on the, or I'll have a line on the inequality. So the solid line, y-intercept at negative 1, slope of 1 over 1. If I plug in 0, it should be greater than, because it's bigger than this line. So y is greater than 1x minus 1 is my equation.